So see here in this particular figure, what exactly, how we are representing the sequential circuit. See here, sequential circuit we are using, this one is the combinational circuit, and we are using some particular memory elements. Okay, so output of conventional circuit also connected is a connected of memory elements, and the output of memory elements is a feedback of input of combinational circuit. That means what? So when the produce the output of a particular sequential circuit, that time what happen? We can use conventional circuit also, and we can use the memory elements also. So whatever output we are getting from the combinational circuit, it is inserted as an input. Okay, and whatever the output of memory elements, it is behave like as a feedback. Okay, and it is inserted into the conventional circuit. So what happen when always we are designing the sequential circuit, use both concept. One is called a combinational circuit, and one is called a memory elements. And what is memory elements? Memory elements are devices capable of storing binary information within them. So we are using some particular binary information for storing purpose, and that for particular purpose we are using the memory elements. Okay. Now see here, when we are talking about the sequential circuit, there are two types of sequential circuit. One is called a synchronous sequential circuit, and another one is called a asynchronous sequential circuit. Are you getting my point? Any doubt? Are you hearing me?
Yes, sir.
You are present or not? You are listening or not?
Yes, sir.
If you have any work, then you please tell me clearly.
Yes, sir.
You are present, na?
Yes, sir.
Yes, sir. Okay, sir. Yes, sir.
Okay, you do one thing. Okay, just a minute. You can turn on your video. All of you turn on your video. Please off your microphone. Off your microphone and turn on your video. Okay, no problem. Okay, you can off your video.
Okay, sir.
But if you are getting any doubt, then please ask me. Don't keep silence. If you are keep silence, then I am not getting anything. Okay.
Okay, sir.
The screen is visible to you?
Yes, sir. Yes, sir. Visual, sir.
So what sequential circuit? There are two types of sequential circuit. One is called a synchronous sequential circuit, and another one is called a asynchronous sequential circuit. So obviously, when there are two types of sequential circuit, that time what when their properties also something different. Why it is called a synchronous, and why another one is called a asynchronous. So at first, we are discussing about the sequential circuit. What is sequential circuit? Okay. See here, a synchronous sequential circuit is a system whose behavior can be defined from the knowledge of its signal at discrete instant of time. So when we are designing the sequential circuit, that time what happen? We are gaining the signal at discrete instance of time, and that type of circuit is called a synchronous sequential circuit. I will explain later. That means how we are designing the sequential circuit and all those things. Okay. So when someone is asking you what is sequential circuit, sequential circuit means what? It is gaining the knowledge of signal, and that particular signal we are applying discrete instance of time. That particular part you must have remembered. Okay. And next one is that the behavior of an asynchronous sequential circuit depends upon the input signal at any instance of time. See what is the difference? So we are taking the input signal at any instance of time. But when we are talking about the synchronous sequential circuit, that means what? That is discrete instance of time. And when we are talking about the asynchronous sequential circuit, that time what happen? Input signal at any instance of time. Okay. So to predict the behavior of asynchronous sequential circuit is something difficult than the synchronous sequential circuit. Okay. So this particular two circuit, how we are designing that particular part we will discuss later. But you have to for the time being you have to know what is the difference. Okay. So difference is that what? That means we can define from the knowledge of signal at discrete instance of time. That time what happens? This one is called a synchronous sequential circuit. And when we are using the input signal at any instance of time, that time what happens? It is called a asynchronous sequential circuit. Are you getting my point? There are two types of stress elements that use in sequential circuit. That's right. So see here, there are now what happened when we are talking about the sequential circuit, that time what happened? We are talking about the some particular memory elements. And memory elements, why we are using the memory elements? Because we are storing the binary information. And binary information means what? It is 0 and 1. Okay. So this particular memory elements, there are two type of storage elements are there, or you can say the memory elements are there. One is called a what? One is called a latch, and another one is called a flip-flops. Okay, so both are so what? There are two type of storage elements we are using. One is called a latch and another one is called a flip-flop. Okay, so flip-flop is nothing but it is one kind of latches. Okay, so at first we know we understand, actually we are going to understand what is the latch and flip-flops. After that, how we can design the latches and flip-flops, that particular part we will discuss. Okay. Okay. So what is latch? A latch is a temporary storage device that has two stable states. One is called a 0 and one is called a 1. And when someone is asking you memory, why we are using the memory elements? Memory elements means what? Memory elements we are using in sequential circuit, and the main purpose of using the memory elements is that the storing of binary information. Okay, so storage elements that operate with signal level are referred to as latches. Okay, so signal level, when we are, that means when we are using the latch, that time what happen? We are using the signal level. So we are using the signal level for that particular purpose. What happen? Latch are said to be level sensitive. Now what is level sensitive? Level sensitive is that means suppose this is the one type of diagram, and so sometimes it is called a timing diagram. That time what happen? When it is the stable point, this one is the, see here, the parallel line. Okay, so this particular line, that means what? This particular line we are considering as a stable state, and it is called as 0. Up to this particular portion, up to it is 0. And again what happen? This is a transaction period, and after that what happen? This particular part is again stable as a 1. Okay, so what happen? Based on this particular signal, this one and this one, so what happen? The latch is, actually we are providing some particular input to the latch. Okay, so in between when this particular 0, when 0 moving to 1, that time what happen? This particular transaction period we are not counting in sequential, no, in latches. So what happen? Either laces is active in this particular level 0, or either lace is active this particular level. That means what? This particular level or this particular level. Okay. For that particular purpose, lathes are said to be level sensitive device. Always remember, lathes are level sensitive device. Okay. So next point, the storage elements those controlled by signal transaction. Signal transaction are called a flip-flop. So signal transaction means what? We are how one particular signal moving to the another signal. That means this is the transaction period. So based on the transaction period, what happened? We are operating the flip-flops. And also, flip-flop is a special kind of latch where a clock signal triggered the change in the storage value. That means what? We are using the signal transaction for that. That means how we are moving from one level to the one particular binary information to the other information. That time what happened? How, which particular situation, that means the transaction is occurred. That particular part maintained by the clock signal. So when we are using the flip-flops, that time what when we are using the clock. But when we are using the latches, that time what happen? That particular latch only based on the signal level. Okay, there is no clock we are using in latch, but clock signal we are using in flip-flop. Okay, so for this reason, latches are said to be level sensitive, and flip-flops are edge sensitive. Remember, flip-flops are edge sensitive device. Why? Because clock signal triggers the changes in the storage value, or always storage elements controlled by the signal transaction. If it is controlled by the signal transaction, that time whatever it is called a flip-flop, but it is not a latches. And latches always depend on the level, which particular level actually signal occurred. Based on their level, the latches are working. Due to this, latches are said to be level sensitive device. Are you clear? Any doubt?
Yes, sir.
Okay. So someone is asking you why latches are level sensitive. So this is your answer. And someone is asking you why flip-flop is a edge sensitive. So this is the answer. Okay. But remember, a flip-flop is also a lace, but it is the special kind of laces. Okay, what is the special kind? That means what? We are using the clock signal. But when we are talking about the laces, we are not using any clock signal concept. Okay, and someone is asking you why we are using the clock signal in flip-flops? Because the flip-flops are controlled by the signal transaction. Okay, so this is the reason. Now we are talking about what is latch and what is flip-flops, and what are the difference between them. Okay, just you remember these particular points. And basically what happens? Sequential circuit, there are two types. One is called a synchronous sequential circuit, and one is called a asynchronous sequential circuit. And what is the difference? You can easily understand from the screen. Okay, and whatever we are discussing. Now see how we are designing the latches. Okay, so when we are talking about the laces, there are different type of laces are there. One is called a SR type, and what sometimes it is called a, why it is SR, it is called a set reset. S means set and R is reset. But generally people are using SR. Okay. D type means what? It is called a delay. D means what? D tends to delay. And JK means jack and the key. Sometimes that particular two words we are using, but generally people are not using that one. People are using only JK. Okay, JK flip flop or JK type. And T is what? T means why we are T type. T type means what? Toggle. Okay. So at first we are discussing what is SR. SR type flip flop. What is SR type? So SR lathes can be constructed from two NAND or two NOR gates. Or you can say SR is a cross coupling of NAND and NOR gates. That means what? We can design SR lathes with the help of NAND gate also, and also, or we can use the NOR gate also. Okay. So what happens when we are going to implement the SR lathes? I am not talking about the flip flop, SR flip flop. I am talking about the SR lathes. Okay. So when we are going to design the SR lathes, that time what happens? We can use either NAND gate or NOR gate. Okay. And what is the behavior? See, now what happens? This is the typical circuit of SR lathes. See here, why it is called a sequential circuit? So always remember, when we are designing the sequential circuit, always sequential circuit depend on two particular components. One is component is called a combinational circuit, and also we are using the memory elements. Okay. So, but when we are discussing about the combinational circuit, that time whatever there is no particular memory elements. So memory elements concept we are not using in combinational circuit. But when we are going to design the sequential circuit, it is the combination of combinational circuit along with the memory elements. Okay. See here, this particular SR lathes we are designing with the help of NOR gate. And this particular SR lathes we are designing with the NAND gate. Okay, this one is the NAND gate. So this one is the NAND gate, this one is the NAND gate, and this one is the NOR gate. See here, here S means set and R this one. So two inputs we are using. S it is one type of input and R is other input. So I am writing here input 1 and input 2. And this one is the NOR gate. This one is the what? It is the NOR gate. You remember, I think. This one is the NOR gate. Okay. See here, the output of first NOR gate. This one is the first NOR gate, and suppose this one is the second NOR gate. Okay. So output of the first NOR gate is connected as an input of second NOR gate. And the output of the second NOR gate is connected of the first NOR gate. Connected as an input of first NOR gate. So why it is? Because see, so all the concept is coming in this particular way. Suppose what happen? I am using two particular non gates here. Not gate. Suppose. Okay. Suppose two particular not gates here. Because we are dealing with the sequential circuit. See here, if we are applying the one, suppose this one is suppose it is the feedback part. Okay. Generally, this particular feedback part, some particular parts we have seen in combinational circuit, but this particular feedback part we are generally seen in sequential circuit. Suppose what happened? This one is 1, this one is 0, and this one is 1. Okay, because we are using two NOT gates. Again, one is connected as an input here. So again, same thing is going on. So that means what? This particular output again behave like as an input of this particular first NOR gate. Some particular memory concept. So what happened? Neither we are providing some special signal. These particular things are stable. That means these particular states are coming. Okay, one by one are coming normally. So see here. So this is the output of the first NOR gate. So 1, suppose here we are applying 0 0. So 0 0 when this one is 0, and suppose this one is 0. So 0 0. So output is 1. Again 1 is connected here, and initially what happened? R value is 0. So again 0 is the output of second NOR gate. Again 0 is connected to this one. So what when feedback connection are connected as an input of this particular two gates. Okay. So because here we are using the some particular memory we are recognizing. This one is the feedback means what? This one some particular memory we can recognize. And this one is the memory. So if this particular circuit, how it is behave, that particular part we are discussing with this particular table. Now remember, when we are talking about the combinational circuit, that time what when behavior of that particular circuit we are representing as a truth table. But that type of table, if we are using in sequential circuit, generally that is not called a truth table. That is called a state table. Why we are using the state? Because what when this particular circuit deal with the memory concept. Okay, so for that particular purpose, this type of table is we are referring as a state table instead of truth table. So automatically someone is saying that this one is the state table, then you can automatically understand this is the behavior of whatever the circuit, that particular circuit belongs to the sequential circuit, not a combinational circuit. Because when we are talking about the combinational circuit, the behavior is representing with the help of truth table, not a state table. Okay. So for that particular purpose, this particular table we are defining as a state table. This one is called a state table. Okay, this one is called a state table. STATE state table. Okay. See here, when S equal to 1 and R equal to 0. Suppose what happened here, S equal to 1 and R equal to 0. That time what happened? This particular Q is behave like as a 1 and this one is 0. Okay. So that means what? The present is that suppose this one is the Q, this one is the Q and this one is the Q bar. That time there are two outputs. Every flip-flop there are two outputs. So what happened? One is called a Q bar and I'm writing this one dash and this one is Q. When S equal to 1 and R equal to 0, and this particular another input we are providing as an output from here. So that time what happened? Here Q equal to 1 and also and Q bar also it is 0. And suppose what happened here, this one is 1. Suppose we are assuming that Q bar is 1 and Q is 0. Suppose we are assuming. Okay. So if S equal to 0 and R equal to 0 and this one is output is 1 and 0, that time what happened? This 0 is connected here 0 0 and this one is always 1 and this one is 0. Okay, that means what? So if you are providing whatever the value of S and R, if output we are predicting as a 1, this one is 1, then it is always 1. And this one is 0, then it is always 0. Whatever the output, if you are providing the input S equal to 0 and R equal to 0, that time what happened? The same output are there. That means there is no changes. So that means what? This Q equal to 1 and Q bar equal to 0. And when we are using the 0 and 1, that time what happened? Q is also 0 and Q bar is 1. Okay. And suppose what happened? If this one is the previous state. Okay, this one is the previous state. If we are taking the previous state and if you are applying the S value equal to 0 and R value equal to 0, that means what? Again 0 0 here, we have seen that there is no changes. So what is the previous state? Previous state is 0 1. So same state is remaining. That means this is also 0 1. And 1 1 means what? We can say this one is the 0 0. And when we are applying the S equal to 1 and R equal to 1, that time what happened? It is 0 0. And this particular part I am discussing here, this one sometimes it is called an invalid state. This one is called an invalid state. IN, invalid state. What is invalid state? Because see, this one is Q and this one is Q bar. If it is Q equal to 1 and q bar equal to must be 0. If q bar equal to 1, that time what happen? Q equal to 0. That particular condition is not satisfied when s equal to 1 and r equal to 1 because both are 0. So this is the violating. Some cases it is violate the rules. So what happen when, always remember, when s equal to 1 and r equal to 1, that is called a invalid state. Okay, and same truth table based on whatever we are discussing, and we can depict it some particular simple truth table. This one is the both are same, but we can what happen based on whatever we are discussing, based on the properties of behavior of this particular table, we can construct in this way. So that means what? When s equal to r and r equal to 0, that time what happen? It is called a NC. NC means what? No changes. NC is what? No changes. That means what? Whatever the outputs are remaining same. And when s equal to 0 and r equal to 1, that time what happen? The q equal to 0 and q bar equal to 1. And when 1 s equal to 1 and r equal to 0, then q equal to 1 and r equal to 0. Sorry, q bar equal to 0. And when 1 1, that time what happened? Based on this particular discussion, this one is called a invalid state. So I am writing question mark. This one is called a invalid state. Why it is invalid state? Because both the outputs are 0 0. But what happened according to the design? This one is q bar. Q bar means what? Q bar is value is always opposite to the q because it is complementary. But here both are 0 0. So that means what? When we are designing the SR-less, you can use NOR gate or NAND gate. It does not matter. When s equal to r equal to 1, that time it is showing that it is invalid state. Same table, same behavior we can representing with the help of NAND gate. But remember one thing, here we are using the S complement. If we don't use the S complement, or suppose if we are using only S and R, that time what happen? This particular table something is changed because invalid state now it is not a 1 1, it is 0 0. But what happen? Don't go to the very confused things. Just you can use S complement and R complement. Suppose here we are using 1 1. This particular 1 1, it is behaved like as a 0 0. When s equal to r equal to 0, that time what happen? If it is 1, earlier state, if it is 1, then same. This is also 1. Earlier q bar equal to 0, then also it is remaining same q 0. But when we are using the s equal to 0 and the r equal to 0, that time what happen? Based on the complement form, this one is called a 1 and r also it is 1. So what happen? It is called a invalid state because from this particular table, when s equal to 1 and r equal to 1, it is providing the invalid state. Why it is invalid state? If it is q equal to 0, then also q bar equal to 0. Okay, so when it is 0 0, that means what? This one is q bar, so it is instead of 0, we can write here 1, but no. When we are providing s equal to 1 and r equal to 1, that time whatever it is must be 0. So it is violating our rules, this particular rules. So it is called an invalid state. Any doubt?
No, sir.
No, sir.
See here, this one is the simple let's. Okay. Other representation is that it is called a gate SR. Let's. Okay, this one is we can use the NOR gate, and this one is this one is the NAND gate. This one is the NAND gate. This particular circuit is the NAND gate, and this one is the NOR gate. See here, we are using the, this one is called a SR let's. So I am writing here SR let's. But apart from that, we are using two NAND gate. So this is with the help of NAND gate. It is help of NAND gate, and sometimes it is called a gate SR. This is also let's. It is not a flip flop. But what you can see here, we are using some particular extra line. This particular E is called a enable line. This one is called a what? Enable line. When enable line is, now we can check what is how it is behavior. What is the behavior of this particular circuit, and that particular behavior we can represent it with the help of state table. So this one is not a truth table, remember, this one is called a state table. So when e equal to 0, that means what? Enable input is 0. What about the value of S and R? Q and Q bar is no sense. You can use S equal to 0, then also it is no changes. If you are using S equal to 1 or no, irrespective of value of R, always it is showing that no sense, no sense. And this one is the part of when the enable input is on. That time what happened? This one is showing this way. So earlier what happened? We know when it is 0 0, that time what happened? It is no sense. It is same. When 0 1, then also it is 0 1. And when it is 1 0, then it is also 1 0. And when it is S equal to 1 and R equal to 1, that means what? It is the invalid state. You just put the value of here. After the class, complete the class, you can go this particular figure and put the value and check how Q, what is the value of Q and Q bar. If any doubt, then you ask me later in the next class. Okay. So what happens when we are using the S equal to 0 and R equal to 0, NC means what? No sense. And why I am telling the NC? What about the earlier value? That means if earlier Q equal to 1 and if we are applying S equal to 0 and R equal to 0, then 1 is remaining same. So I am here I am using no sense. But what happens when S equal to 0 and 1 equal to 1, that time what happens? Q is always 0. You can put the value here, then automatically you can get Q equal to 0 and Q bar equal to 1. And when we are applying 1 0, that time what happens? Q equal to 1 and Q bar equal to 0. But remember always, when both S equal to 1 and R equal to 1, that time what happens? Q value is always 0 and Q bar is always 0. That is not true actually. That is not a correct state. That is invalid state. So here I am using the question mark. Same thing if we are applying the NOR gate. So this one is the simple NOR LEDs, and this particular NOR LEDs connected with the 2 AND gate. And extra what happen? We are using the enable. And if you are applying this particular circuit, that time what happen? Same state table are generated. This one is called a same state table. Here also when S equal to 1 and R equal to 1, Q value is also 1 and Q value is also 0 and Q bar is also 0. That is not true. Okay. And R also similar. And this one is called a let's sequential. Get SR let's with the help of NOR gate or NAND gate. Any doubt this one?
No, sir.
No, sir. No, sir.
आप लोग नो नो ऐसे ही बोल रहे हैं कि समझ में सही में आ रहा है? या सेकंड इंटरनल का मार्क मिला?
Yes, sir.
Yes, sir.
आप लोगों का तो the first week of or second week of December your course will be completed. But I don't know, your exam may be end semester exam in the month of March. And because
Sir?
I'm not, yes.
When will be the midterm, sir?
That particular part exactly I don't know because till now admission process is going on. ठीक है? फर्स्ट ईयर का अभी तक एडमिशन कंप्लीट नहीं हुआ है, तो ऐसा तो नहीं होगा कि मिड सेमेस्टर फर्स्ट ईयर के लिए अलग तुम लोग के लिए अलग होगा, ठीक है?
Yes, sir.
फिर भी तुम लोग रेडी रहो. तुम लोग का मिड सेमेस्टर मंथ ऑफ दिसंबर नहीं तो फर्स्ट वीक ऑफ जनवरी होगा. ऐसा भी हो सकता है कि फर्स्ट ईयर के लिए इस बार अलग से मिड सेमेस्टर ले, ठीक है?
Yes, sir.
तो आप लोग कोई भी हो, ऑनलाइन हो ऑफलाइन हो, उसके बारे में आप लोग को सोचने की जरूरत नहीं. आप लोग को सिर्फ क्या काम है? आप लोग को एग्जाम देना है. ऑफलाइन में ऐसा होगा, ऑनलाइन में देने से ये इजी होगा. इट इज नॉट लाइक दैट. आप लोगों को क्या करना है? यू कैन क्लियर योर ऑल द कॉन्सेप्ट. You can clear your knowledge. You are gaining your knowledge. That's all.
Yes, sir.
और
Yes, sir.
कब मिड सेमिस्टर होगा उसके हिसाब से आप प्लान मत कीजिए. सर ने जो पढ़ा है उसको मैं कोर्स रेगुलरली कंप्लीट करके जाऊं. दैट इज योर मेन ऑब्जेक्टिव. बाकी एग्जाम नहीं होना वो आप लोग का टेंशन की बात नहीं है, वो हम लोग का काम है. ठीक है, लेकिन आप लोग का कॉन्सेप्ट क्लियर कीजिए. ठीक है.
Yes, sir.
Yes, sir.
So whatever we are discussing, that is called a gated SR LEDs. So both the diagram, it is one is representing as a with the help of NOR gates and another one is NAND gates. And this particular table, it is not called a truth table, and this one is called a state table. And why we are calling a state table, that particular part I have already discussed, because it is deal with the past information or memory elements. Memory means what? Some particular previous information we have recorded. Okay. But when we are talking about the combinational circuit, that time what happened, we are not dealing with any particular memory elements. Thus whatever the output में जो input में जो होगा उस हिसाब से output आएगा. That means output always depend on input. So there is no concept of memory. But here we are using the concept of memory as well as the combinational circuit. The output of combinational circuit. Okay. Now what happened? This one is called a delay. Delays. So how we are designing the delays? This one is called a, see, this one is called a normal. If we are this particular part is called a NSR LEDs with the help of NAND gate. It is similar to the simple SR LEDs. Apart from that, we are connecting with the two NAND gates. This one is the NAND gates and this one is the NAND gates. And delays we are using with the help of this particular diagram with the help of NAND gates. But when we are talking about the NOR gates, at that time what happened? This particular part is called a SR NOR gates. Okay. And when we are going to design the delays, that time what happened? Externally we are using the two input and one inverter from D. And this one is the enable input. Okay, this one is the enable input, or you can say this one is the E. No problem. Okay. Now see here, in this both the circuit, we are using only one input. But when we are talking about the SR LEDs, we are using two inputs. One is S and one is R. S means what? Set, and R is reset. And when we are talking about the D means what? Delay. Okay. Now see here, and here also we are using, oh, this one is, sorry, this one is actually SR. This one is not a D flip-flop, okay, because we are using the two inputs S and R. This is the SR flip-flop. So don't consider this one is the D flip-flop. This one is not a D flip-flop. This one is the D flip-flop. Okay. See here, and with the help of NOR gates, because we are this particular part we are using the SR LEDs, this particular portion. Okay. See, when enable is 0, that time whatever the value of D, the output is no sense. The previous output is remaining same. If Q equal to 0, then also if E equal to 0, then also it is 0, and the Q bar also 1. Suppose if it is 1 earlier, then also it is 1. So whatever the value the earlier, that particular value is remaining same. That is the meaning of NC, no sense. Okay. But when the enable E equal to 1, that means enable is on, E signal is active. That time what happen? If D equal to 0, then Q equal to 0. Are you getting my point? When enable is 1, D equal to 1, you can put the value here, then you can get this particular, suppose this one is Q. When D equal to 0, this particular value is 0, you can try yourself. That time what happen? But you can consider whatever the value, it is maybe 1 or maybe 0. And whatever the combination you can consider here, it is no problem. You can consider any combination that time, but remember D equal to must be 0. Okay, that time what happen? When D equal to 0, that time what happen? Q is also 0. When D equal to 1, that time what happen? Q equal to 1. Meaning is that whatever the input, it is behave like as a output of Q. So obviously when Q equal to 0, that time what happened? This Q bar equal to always 1. So here I am writing 1. Because this one is Q and this one is the Q bar. Okay. So if it is 0, then it is 1. If it is 1, then it is 0. But main important thing is that, see here, whatever the input 0, 1, it is input is same. It is also 0, 1. So if D equal to 0, then Q equal to 0. If D equal to 1, then Q equal to 1. So that is called a gated D LEDs. And if we are using the NOR gates, NOR SR LEDs, that time what happen? We are using the 2 AND gates here. And apart from that, one particular AND gate we are using as a NOT gate. This one is the NOT gate, and it is connected with D. This is the structure of this particular circuit. And if you are finding the behavior of this particular circuit with the help of state table, then this one is called a state table. Okay, this one is not a, because I'm going to design the NAND gate. So because here it is set and reset, this is not a LEDs, not D LEDs. It is the normal SR or gated SR LEDs with the help of NAND gate. Okay. So don't consider this one. So you can try for D LEDs with the help of NAND gate. ये मैं NOR gate के लिए आप लोगों को दिखाया. NAND gate में क्या होगा? You can try yourself. Okay. And next class you can tell me, sir, this is the NAND gate, and also you can see yet this state table actually follow or not. If it is, why it is follow exactly. Okay. So here what happened, instead of NOR gate, here we are using the NAND gate. ये यहाँ पे क्या यूज करेंगे हम लोग? NAND गेट यूज करेंगे. और ये दो गेट क्या होगा? ये भी NAND गेट हो जाएगा. ओके, ये यहाँ पे भी NAND गेट होगा. But we are not using here NOR gate. You can just check from the book and you can just observe this particular state table is working or not in that particular circuit. Okay. So today the students are very less. And remind me, sometimes what happens, some my work actually I am getting late for 10 minutes or 20 minutes. मैं बस WhatsApp में आप लोगों को message भेजा था. The class will be started 9:30. I have a one particular conference, so I am getting late. So I am starting my class 10 or 15 minutes late. So that means what? मैं पहले क्या बोला था 9:30 में होगा, मैं 9:46 में शुरू किया. लेकिन आप लोगों ने कोई भी लड़का ज्वाइन नहीं किया. And I am strictly follow the attendance for today. जो लड़का आज attend किया है, that means उन लोगों में अटेंडेंस के लिए कुछ उन लोगों को बेनिफिट मिलेगा. एंड ये मैं किस लिए कर सकता हूँ? एक एक टीचर क्लास में अगर 10 मिनट लेट आएंगे तो फिजिकली जब क्लास होता है आप लोग सला जाते हैं क्या? बाहर निकल के सला जाते हैं? नहीं सर. अगर क्लास अगर ऐसा भी होता है ना, कोई आप लोग का जब फर्स्ट ईयर का क्लास किया था आप लोगों ने, आपको 10 बजे क्लास होता है तो सर साहब सपोज कोई काम से 10 पे आया, बाद 10:05 पे आया, तो 5 मिनट लेट होने के कारण सब लोग उठ कर चला जाते हैं क्लास से.
नो सर.
तो मैं आज 9 बजे क्लास होने वाला था, मेरा एक कॉन्फ्रेंस था, इसलिए मैं आप लोगों को व्हाट्सएप में मैसेज भेजा सुबह 7 बजे करीबन 9:30 में क्लास होगा. लेकिन 9:30 में मैं एग्जैक्टली शुरू नहीं कर पाया, 9:46 में मैं शुरू किया. तो अभी तक कोई भी लड़का आज अटेंड नहीं किया, सिर्फ आप लोग के 3-4 लड़के छोड़ के. जो आप लोग का जो लड़का ने आज किया है उन लोग का रिकॉर्ड मेरे पास है, and you will get the special benefit, and this particular message pass to the all the information, yeah, pass to the all the students. मैं जो बोल रहा हूँ वो उन लोगों को बोल दीजिएगा आप. ठीक है सर. और स्पेशली क्लास रिप्रेजेंटेटिव को. ऐसा नहीं है कि आप लोग एग्जीक्यूटिव हैं. यू आर टिल नाउ यू आर द स्टूडेंट्स एंड बिहेव लाइक एज ए स्टूडेंट्स. ये ऑनलाइन क्लास हो रहा है, इसका मतलब ये नहीं है कि एकदम पूरा एकदम समथिंग इज डिफरेंट फ्रॉम द नॉर्मल क्लास से बहुत ज्यादा ये डिफरेंट है. यही चीज मैं आप लोग को ब्लैक बोर्ड में समझा था. आप लोग का फेस टू फेस इंटरेक्शन होता, तो आप लोग को क्वेश्चन, आप लोग का कुछ डाउट होते तो मुझे पूछते. वही चीज यहाँ पे ही हो रहा है. ठीक है. तो बी ऑनेस्ट एंड बी सिंसियर. It is not like that, yes, you are getting the out of 10 you are getting 9, 10, the internal marks is something like that. It is not like that. Yes, it is, you are doing very good. Okay, if you are getting 9 out of 10, that means you are yeah. But this one, remember, this one is the multiple object type, because otherwise I have a no option. But End semester, mid semester is something different. So be prepared for that one also. Mid semester में don't expect that the question is coming in optional type of question in mid semester exam. Don't expect like that. Okay, so maybe question pattern is something different. Maybe we are providing some type of descriptive question or different type of question, and I am giving the your time constraint is fixed. So maybe whatever it is not like that. आप उसको फोन करके क्या हुआ उसको फोन कर that means lot of I know lot of anomalies is going on that particular multiple objective type question. So आपको 9 मिला है 10 मिला है आपको इंटरनल अच्छा जा रहा है then if you are honestly if you are working very hard then it is okay good it is also good for you also okay but if you are collecting the answer from somewhere else और मुझे तो मिल रहा है मुझे क्या मतलब है मेरे नॉलेज से क्या मतलब है मुझे तो मार्क मिल रहा है but don't think like that because the two great exams are coming one is mid semester and end semester अगर आप इंटरनल में अब बिना नॉलेज का आपको किसी का हेल्प से आपको मार्क मिल रहा है ठीक है नो प्रॉब्लम लेकिन एंड सेमेस्टर मिड सेमेस्टर में क्या करेंगे इसीलिए डोंट थिंक लाइक दैट बी सिंसियर बी ऑनेस्ट रेगुलरली स्टडी योर क्लास मटेरियल व्हाटएवर आई एम डिस्कसिंग and try yourself if any doubt you are getting you just ask me in the next class or otherwise I have no option मैं इतना ही बोल सकता हूँ as a teacher आप लोग को डाउट मुझे कुछ भी नेक्स्ट क्लास में आप कोई भी लड़का मुझे डाउट नहीं पूछते so if it is well for you also if you are asking your doubt regular session are you getting my point
yes sir पूछेंगे सर आपसे
Yes, sir.
okay uh, uh, okay then tomorrow we will start our class what 10 to 11 okay
Okay, sir.
yes, thank you sir
Thank you, sir.
just you please leave one by one
okay sir